This is Unit 5, Lesson 2, Pet Sitters. Today we're looking at a very complicated problem that has what we call constraints. Constraints are things that limit what we can do. So in our story about Carlos and Clarita, they're going to hold cats and they're going to hold dogs, and kind of like a dog hotel or dog-cat vacation. They are limited by space and how much money they have. Those are their constraints. Now, as we read through each of these, we can see that there are some numbers that naturally want to be with variables. Like 6 square feet is obviously per or with each cat. Their pens, that would be their storage area. And a dog run is kind of like a storage area for dogs. It allows them to run back and forth, and that's about it. That size is 24 square feet per dog. So those are the numbers that are going to get multiplied by the variables, and then there's another number that's 360 square feet. That's the total. Now for startup costs, it does use the keywords for each. So if you see per, for each, or for every, those are usually the numbers that get multiplied by the variables. Now, there's another paragraph here that talks about their profit. It says that they plan to charge $8 per day for a cat and $20 per day for a dog. Spoiler alert, those are not constraints. They do not limit what can be done. They're just simply reporting on what's the profit. So the first thing we did is we looked at what a possible chart would look like. The dad recommended 12 cats and 12 dogs. And when you do that, you're okay with your space. It has to be 360 square feet or less. But what the problem you run into is it costs too much money. It costs $1,344 to build or to buy these pens and dog runs, and so they would be out of money. Now, what if they did all dogs? Well, then it would be too much space. That would be 384 square feet. If they did all cats, then they could fit exactly 60 pens for cats, which is 360 square feet. But that would end up costing $480, way less than they want to spend. So they're not really utilizing the space effectively. So it checks out as far as is it possible, but it's not necessarily how you're going to make the most money. So then what we did is we translated what's going on with dogs and cats with as far as space and money into equations. We get 6x plus 24y equals 360 for their space, and 32x plus 80y equals 1280 for the money. X is the cats, the number of cats, and y is the number of dogs. Then we looked at Desmos. So looking at Desmos, if we look just for the intersection of those two equations, there's a problem. You get fractions. And we can't have fractional pens. It's either got to be complete or not. So we started looking for points that were around the intersection that were whole numbers. Now 613 is one that works, but so does 713. 813 is outside of what's possible. In fact, it's outside of that purple line. Now, when I say inside and outside, what I'm talking about is an inequality. And if we change these equal signs to less than or equal to signs, now you see the shading. And so the points have to be shaded for both colors. It has to work for purple and green. And so it's down to 613 or 713. Which of those 2 points is going to work? And I set up a function to evaluate that, 8x plus 20y. And 713 seems to be the best choice. 7 cats, 13 dogs, or 7 cat pens and 13 dog runs. And they'll be able to make $316 a day. So they're really going to clean up. So going back to the workbook then, 7 cat pens, 13 dog runs gives you $316. Now let's look at the takeaways from this. In pet sitters, the statements about startup costs and space are called constraints because they limit the money and the space. A viable or a possible option for the space constraint includes 12 cats and 12 dogs because that's within the limit for both, actually. The pet sitter's context can be modeled with a system of linear inequalities because we have space and money constraints. We have to look at both. In the pet sitter's context, Carlos and Clarita want to maximize their profit. The statement about profit is not a constraint because they're not limited by their profit. Instead, profit is the result of their choices. How many cat pens, how many dog pens do they build? Okay, this is the end of the Launch, Explore, Discuss. It was a very complicated problem that had to be analyzed using algebra. We'll see you next time.